of a circle to bisect a curve is perpendicular to that curve. And I say when you say bisect means to divide into two equal parts. That was the first theorem we did. The second one says angle at the center, or let me put it this way, the angle which an arc of a circle subtends at the center is twice the angle in which it falls on the circumference of the same circle. And I gave you examples of that. It is from that one I brought out another theorem, which is angles in the same segment of a circle are equal. After that, we also talked about angle in a semicircle is right angle. These are the theories that we discussed. Now, let me go to that last theory. This is the diameter. Any angle that forms like this must be a right angle. That's the law. Let's say we have another one here. This angle is 90 degrees. The theory we're about to discuss today has to do with what we have on the board. If I play this, there is no more diameter. But when you look at this opposite angle, this is 90, this is also 90. You can say that the two of them add up to 180 degrees. I will label it. Angle ABC plus ADC is equal to 180 degrees. From where you looking at the diagram, we have not started the theory. But with what you are seeing on the diagram, the two of them add up to 180 degrees because this is 90, this is also 90. Now, I want to look at this shape. A, B, C, D. What do you call it? Adebola?
Sir, is it rectangle?
Remove the circle. We are only talking about A, B, C, D. What do we call this one? Remove the circle. Or maybe I should draw something like that.
Quadrilateral.
God bless you. Quadrilateral. God bless you. We call it a quadrilateral. So that leads us to today's topic, which we call cyclic quadrilateral. Cyclic quadrilateral. Cyclic in the sense that what? All the four angles are on the circumference. Please don't make that mistake. All the four angles must be on the circumference before you call it cyclic quadrilateral. You have to take note of that. If one of the four angles is not touching the circumference, that means it's not a cyclic quadrilateral. What I want to say is that whatever you want to draw a cyclic quadrilateral, you must make sure that all the four angles are on the circumference. Then we refer to that one as a cyclic quadrilateral. What does the theorem now say? We have stated the theorem. The theorem says opposite angles of a cyclic quadrilateral are supplementary. Let me write it down. Opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. And the clear example is on the board. So, A, BC plus ABC is equal to 180 degrees. Also, BAD plus BCD is also equal to 180. Addition of this one is 180. Addition of this is also 180. Don't forget that in cyclic collateral, all the angles add up to 360 degrees. So if two of them add up to 180, the remaining two must add up to 180. That is the theorem. Opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. I hope that one is understood.
Yes.
Okay. So, it may not be 90 degrees. If I say this angle is like, let's say, 92 degrees, angle ABC is 92 degrees, then I can find my what? Angle ABC. It means this one must be 180 minus 92. And what would that one give us? So that will be 88 degrees. If I'm right. Because my calculation is somehow now. My addition and subtraction. I don't know what's wrong. Are you getting me now? So if I say this is, if I say this is one, let's say this is 182 degrees. Then to get the opposite of that one, that will be 78 degrees. It's as simple as that. Is it, you know, I said something when we started this circuit geometry, that there is no particular formula. You only need to know the theorem. Once you know the theorem, how do I apply the theorem? Those are the tactics behind the circuit geometry. Do we have question on that?
No, sir.
Good. So this one takes us to the other part of cyclic collateral. We say the exterior angle of a cyclic collateral is equal to the interior opposite angle. This is a circle. Look at it. The exterior angle, where is the exterior? That's outside. Outside that collateral. The exterior angle of a cyclic collateral is the exterior angle. Is equal to the interior opposite angle. Interior opposite angle. This is the interior opposite angle. These two angles are equal. It means A is C must equal to what? C is C. It's a very simple way of, you know, telling us that what angles on a straight line add up to 180. But we know that addition of these two is already 180. Also, addition of these two is 180. Definitely, this and this must be equal. Let's use the figures. Let's assume that.
Yes, sir. You say the exterior angle of a cyclic quadrilateral is equal to the opposite exterior angle.
It's equal to the opposite interior. Interior, not exterior. The exterior angle is equal to the interior opposite angle. And this is the interior opposite angle. Are you clear with that?
Yes, sir.
So let us assume that this is, let's say, 87 degrees. Based on the previous theorem, opposite angle of cyclic collateral add up to 180. Then we can calculate this. So when we calculate this one, this will be like 93 degrees. And based on the theorem, we say angles on a straight line add up to 180. This is a straight line. So the adjacent angle add up to 180. Then to get this one, subtract this one from 180, which is 87 degrees. You cannot see that they must be equal. It's a very simple logic. The two of them must be equal. Do we have any question on that?
No, sir.
Good. So let's see how we can have some questions. I'm going to solve some questions on this cyclic collateral. Don't make it too complicated. Let's start from a simple question to other ones. Okay? This is let's learn it. A, B, C, D. Want to find this angle. Find A, B. You have to find angle A, B, C.
You said those, one of the other theorem is that the angles in, what is it? The angle of an arc which subtends at the center is half of the angle which subtends at any remaining part of the circumference. So we can find ABC like that.
You did not say the theorem very well. I have to say that theorem. Not the idea of what to do, but the way to say the theorem will convince you along the time when you are taking that. Get the theorem back. Follow the theorem.
So the angle which an arc of a circle subtends at the center is twice which is subtends on.
It's twice. Very good. It's twice. So, which angle will not be out of? Let's say that which angle will not be out of A?
So is it ABC?
ABC, very good. ABC is half times the center of a circle. Yes, so this is how I think it is. For it to know that one, answer the center why you want to attack one. That's the way. So this one is AC, that's 43 degrees. So how do we now put it AC? How do we find AC?
So ACC, since they are both opposite, since they are equilateral, since they are equilateral, etc. Then we can. Yes, sir. This is a. Wait, no. No, ABCD. Yes, sir. Since ABC and ADC are opposite angles, so that means they'll be supplementary. So we can do ABC. No, 180 degrees minus ABC, which is 43, to get ABC. Now your reading is equivalent, just like for the last era. So when you find that one, that will be 1. You can tell the matter of understand the theorem and follow it religiously. Once you understand the theorem, you follow it the way you're supposed to do. There is no particular formula here. No formula. Just a matter of understanding. I hope no one is taking. Yes, sir. So, let's see an example. We want to find out angle with this diagram. How do we find the mass angle? I think I understand that all those enter. Am I ready? Sir. What do people do to relate to this? Yes. Wonderful. Yeah, forgot to diagram. I'm going to punish you. You know the question I will give you. You know the question I will give you. You know the question I will give you. We start the class. This one will not see me. He will not see me. Okay, you're welcome. Yes, sir. Thank you, sir. So, how do we find this man's angle? I never had one idea. Angle, sir. The math one. This particular one. Okay, let me do the math. So that no one can see. Let me put that up. Sir, we can make an angle between P and S. Between P and S. There will be an angle between P and S. Wait. This is Yes. So I find that value of sir. Yeah, the X is 2X. Which one is
two
the 12 is the X to be 12 is yes to find X. Anything you get in O, it will be 12 is to find X.
I don't get it. I don't get it. How to get there here to go. Uh-huh. One.
PSR and POR. No, PSR and PQR are opposite angles.
PSR and PQR. They are opposite angles.
Answer, use that one. You can just find PSR. To find PSR, we'll get if we find PSR, that is 180 minus 73.
180 minus 73. Find something now.
But if we find PSR,
I said you just want to go something. Honestly, it's wrong. It's not wrong. But why so the fact that for one is to get this one?
Because to find the inferior angle of because
we don't get the one to hold the body. I'm going to do that, am I right?
yes sir.
What we are going to see now that this 73 plus this angle is equal to 180. Fine, you are right. But why is it equal to 180?
Sir, this is because angle on a straight line.
It's more than that. It's not more than that. On a straight line. That's what I want to show. What I want to angle on a straight line. They are very close. That's 001. That's 107 degrees. Okay?
And then PQR is the opposite of RSP. Means the exterior angle is equal to the opposite interior angle. So that means PQR is equal to 73.
It's also equal to 73. Okay? That is fine. It's 73. Okay? But you know, this is what you are doing. Someone is coming from Lekki to VI. And someone is coming from maybe Obadele to VI. I'm with you. Let's go to our destination. When you from a zero angle is equal to the zero opposite angle. You are right. So, how do we let us calculate the small size. Let us use. You are right. What is wrong with this one? We are going to solve it in 2 ways.
Right, sir. Sir, that means
Solve it. I want to know that whichever aspect you understand, you can choose that one to get to. We are cutting this one as 107 degrees. And for the first cut is second theorem, yes, that we treated on Monday, that says alpha at the center, the one at the second plane. So we say that one, this angle is angle of this. That's what it is. 107 is out of the angle margin. You can say this one is small, and that's what I want is. What I want is this reflex angle. Reflex T2R, which is our angle S, equals to 2 times 107 degrees. I will multiply that down to 214. This one is angle at the center. That's 214. Now, that that will be optics now. Optics, sorry, POR is 73 times 2. This is using as angle. So that will work. That will be 146. So this angle now is 146. If this is 146 degrees, then alpha is the point. Angle to 60 degrees. So that is equal equals to 36 minus 146.
Hasan, yeah.
This will be 1, this will be 2. That's 2. Angles are
Hello, sir. Hello, sir. The last part. Not.
whether you use
It's
the
not
first
clear.
approach or you use the second approach. Because the examiner too will be trained that a student can choose this kind of approach or can use any other approach. What they need to do is just to look into what you have done. If what you have done is in line with what they want, then you'll be giving your full mark.
No, sir.
Questions? Almost yourself and let me see if there's any questions. More example.
No question, sir.
That's the area of there's one particular question that came across. Sometimes it goes. What else you look at that question and see what you can do. So that means there's no question here. Let's see how we can solve it. Let's see how we can solve it. I'm looking for example. And then what I would like to move yourself. I do always say what's not for you only want something. And I say that we all discuss. You bring your idea. Whatever we say, don't think it's wrong. You understand? That's the way to do it. And if that's the way to do it, if there's any mistake there, you should correct it. So, and listen, how do you find the value of n? After the research, there's anything that is very useful. Okay, no problem. There are ways to solve this. There are ways to cool. I can just find the reflex angle
equals to 360 minus 360. That's angles at the point. So when I subtract that, that's 4, 5. Sorry, that is sorry. It's something like 2. I'm very sorry for that. That's 154. 154. So this angle now, how do you calculate? 154. From there, this one is half of it. Then I can say x plus 3 equals to 1, 5, 5 over 2. That's the angle at 5, 1, 5. You want to see that with it? Your first point is find this one, this particular angle is half of it. So that will give us 3, 6, 5 by 2. And 2, 6, 5 by 2, 1, 0, 3. So based on scientific philosophy, this plus this, that is 1 this, then just 1 3 minus 1 0 3. Let's do that 2 gets 7. You can use full approach. This answer is okay. Always start with study the diagram and look at which of the theorem is applicable. Look at which of the theorem is applicable so that you know how to approach that particular. Hello. Anybody have an idea of what to do? PRQ and PSQ opposite angles. PRQ and PSQ opposite angles. I can't hear you. Hello, sir, can you hear me, sir? Can you hear me, sir? Hello? I know I can see that you are raising your hand, but I cannot hear you anywhere. Sir, you can't hear me. Sir.
So I need to log out and come back in.
Okay. Yes, I can hear you, Mr. Can you hear me?
Mr. Yakub.
Yes, I can hear you, sir. Okay, I think he has network issue. Abdullah, allow him to. He has left and I will rejoin now. Now, Mr. Additional, can you hear me, sir?
I can hear you now.
Okay. It's your network then. Abdullah, over to you. You can talk now.
All right, sir. Sir, is PRQ and PSQ opposite angle?
What did you say?
PRQ and PSQ opposite angle?
Opposite.
Okay, sir. Then that means PSQ will be 180 minus 105.
What's the reason behind that?
Because they are opposite the cycle quadrilateral.
Cyclic quadrilateral. And that gives you 75 degrees. Look at the diagram. Look at how the diagram is. And look at the solution. So, what you do is that one. This self-directed, how you don't know people that you can study. You can't don't know people. Some people that are studying, they will come down to them. I want to say something is one, that one, 2, 1, 0. Okay. After they calculate this one. That's 360, 210. What does that one give you? 0, 5, that one 50, 150 degrees. The same time is what? 150 degrees. And this angle is square. They will not say our LQ equal to half of 150. It's 75 degrees. How can I see the way by which we will do the question and the approach that is expected of you? That's what it is. The approach that is expected of you. Like what Mr. Yap always says, don't forget, what we are doing is just like an introduction. Are you getting it now? It's just like an introduction. After the class, forget about the question that Mr. Yap will go to, set for you. That one is on its own. You should pick your textbook. Pick your textbook. Go to the questions on textbook geometry. Back to some of them that are related to the theory that you have discussed. Okay, this is the way you want to approach. Okay, if I see a similar question, you have this to do. That's what can make you to stand out. You can be and stand out. You stand out on the whole class. So that by the time you have to write, you should be proud of yourself. Almost of them are this line. I know you are really you are left out a bit. You are left out a bit. And I don't want you to be left out. You understand? I don't want you to be left out. I want you to know whereby by this time in maybe August or maybe July or August, you come and retire to tell you that those students who attended our meeting that time, they have paying mathematics. So if you said it's theory, when you come to the class,
Yes, sir.
good. You remember we said some theorems, and there was one we said that talking about angle is everything. So, this is the theory we said today. ABCD is a quadrilateral. ABCD is a four-sided plane shape, and a four-sided plane shape is a quadrilateral. But you notice that all angles on the four-sided plane shape are on the second plane. So the other angle that on the second plane is just a side quadrilateral. Side quadrilateral. And in this case, All angles of the side collateral are supplementary. That is, this one and this add up to 180 degrees. ABC plus ABC is equal to 180 degrees. Or BAC plus BCD is equal to 180 degrees. That's the first theorem repeated today. The second one repeated is what I'm talking about the exterior angle of the cyclic collateral. Exterior. If I set this line now, I have a exterior angle of that cyclic collateral. It's not more part of the space. So rather than this particular angle is equal to this two angles are equal. This is very, very important. And that's the example I give. So I think this one is 93 degrees. This also must be 93 degrees. And don't forget that this line is a straight line. So by straight line angle, you get the exterior one. After getting apply exactly the theorem, adding this together to give one day. That's just the theorem that they have been using. So that it will not be the kind of big issue that what are they saying this morning? They are talking about the cyclic collateral. Let me look at this time. Let's see. Oh, did I happen?
Yes, sir. Which is sir? Hello, sir. Can you hear me? Abdullah, can you hear me? Abdullah, can you hear me? Hello, sir.
Oh, I thought maybe you're off now.
Yeah. You called me.
I call your name.
Yes, yes.
I look at the time.
Uh,
I look at the time. I don't know.
we still have time. We have about 16 minutes.
Okay. Let's listen to it. Calculate the name AC and the radius of circle. Okay, that's a question now. How do you find the length AC? Adewala, you need to unmute yourself. Unmute yourself.
Yes,
Unmute
sir.
yourself. Just unmute yourself permanently. We have 15 minutes.
All right,
What
sir.
to discuss? What to discuss? So how do you find length AC?
So I have to ask a question. The question
Go ahead.
is AC a diameter? Does it have a point in between?
Okay. Adewala, can you answer that question?
Sir? AC, the sir is a diameter.
Is the diameter. I told you, whenever that point is there, this point indicates the center of the circle. That means AC is the diameter. So we are getting there. So how do we now find like AC? I'm with you.
Ah. God.
Is it difficult?
Mm. Okay. AC is equals to. We can use Pythagoras. No, we can use trigonometry ratio to find AC.
Okay, I'm with you. I'm with you. I'm with you. Go ahead.
The the opposite side, 5 AB is the opposite, while AC is the adjacent. Then BC is the hypotenuse.
Are you sure?
Yes. AB is the opposite, BC is the hypotenuse,
Huh?
C is the adjacent.
Yeah, that's the line.
Yes,
Yeah,
sir.
the line.
Sir,
Olayemi o.
Can I ask you a question?
Sir?
Can I ask you? Go.
Yes.
Why did you say that we can use trigonometric ratio?
Because you gave a angle and a length. Assuming there is two angles, you can find, you use cosine rule. If there's, how would I put it? Yes, if there's two angles, you use cosine rule. And if there is
Okay.
one angle, you use sine rule. And the sine rule in the sense that it will be trigonometry ratio.
Okay. We have an idea, and I really appreciate your effort. Sincerely speaking, I really appreciate your effort. All this circle geometry is always funny. That's why I said you must know those theorems. Remember on Monday we teated a theorem which says angle in a semicircle is what? 90
90
degrees.
degrees.
This angle is 90 degrees. Before you use figure ratio, the angle must be 90 degrees. That's the condition. Not because it's one angle or because it's one side. No. It must be what? 90 degrees. And if it is 90 degrees you have here, this line AC is the hypotenuse. But AC must be in front of what? Angle 90. That's a standard rule. So the opposite is line. This is line AB. The adjacent is line BC. Therefore, the hypotenuse must be what? Line AC. So we are still going to apply figure ratio, as you rightly said. Now, to apply figure ratio, let me go into what angle for you to see what we actually do. This is what we have. This is 30 degrees. This is 5 centimeters. And this is 90 degrees. This is opposite hypotenuse. Opposite hypotenuse. That is sine. So we can say
Yes.
sine 30 degrees is 5 over 9
5 over
AC.
AC.
Isn't it?
Yes, sir.
Good. So what do we have? AC sine 30 degrees is equal to 5. That means line AC is equal to 5 divided by sine 30 degrees. Please, what is sine 30? I don't have a calculator, I don't have anything here. No calculator, no nothing. Fire sine 30, sine 30.
0.5, sir.
0.5. That's 5 divided by 0.5. It is
Equals to 10.
10.
10 centimeters.
So we are done with this one. We have answered the radius of the circle. What is calculated now, applying AC, is our diameter. Therefore, radius must be equal to half of the diameter. That's half times 12. Which is 5 centimeters. It's as simple as that. You can see how simple it is, but the diagram looks somehow complicated. it goes back to what I said. Don't look at the diagram as something that looks, cumbersome. Look at it as something that is talking about theorem. Which theorem am I going to apply? Which one is applicable? Which one will I use? Those are the things that you actually need to do when you are dealing with circle geometry. So, before we round everything up, I personally want to get the feedback from both of you. What have you learned for the past few weeks we have been discussing? I think this is our first lesson.
Sir, it's mainly the cyclic quadrilateral.
What do you think?
Sir, the circle geometry, everything of circle geometry.
So, did you benefit anything from circle geometry?
Yes, sir.
Yes, sir.
Okay. What about the sorry? What about the differentiation?
Yes, sir, that one as well.
Sir, that one
Okay,
as
that
well.
one.
It's a very nice.
So, as well now, maybe you have friends that say, okay, I need people who will coach me from mathematics. Can you recommend smart math? You can recommend smart math. So, meaning that for what Mr. Yaku posted on the group, we should be expecting, let's say, hopefully, for those that we have added classes together. I don't know what that means for today. Mr. Yaku.
All right, thank you so much, Mr. Additional, for your time. We pray that may Allah reward you abundantly for this wonderful job you have done. So, to our wonderful students as well, so we wish you the best in your upcoming exams. And as I've said earlier on, that this is not the beginning. This is not the